actually taps the black box. But I can show off the axes checks for the gun assembly.
All right.
All right. So I've got to get another set of servos, gearboxes, another 9-piece channel here, and then of course another gun from somewhere.
Throw it on the other side.
On the other side. But anyway, the big thing that I've been working on is getting the Raspberry Pi to be able to read from the eyes that are inside the gun. It's an infrared emitter and receiver, and so it's like a pretty standard brake beam setup. And then have the Raspberry Pi drive the solenoid, which would control firing the gun. I'll start with a solenoid. So after a little trial and error, this is about 10 BPS.
Can't see anything. That's pretty cool.
So
it's firing now.
That was 100 shots. Now, I wanted to see how fast it would fire. Yeah. And I got to the limits of this is a bash script that's driving it. So I got to the limits of what this particular version of Sleep would handle in terms of time resolution.
Okay.
And
I think there's a U-Sleep maybe that will handle microseconds.
Well, so this version of Sleep does handle microseconds.
Oh, nice.
It'll handle it down to like a millionth of a second.
Okay.
Oh, no, don't throw that flag.
But anyway, so here's as quick as I got it to go.
That was no flag.
It turns out that's about 50 BPS, give or take.
This is not approved of by the Proto Corporation, I'm sure.
Yeah, so I pretty much quit as soon as I saw like what the fastest I could possibly cycle this thing was, because I don't know.
That's just not physically possible.
I don't know of a hopper that could drive paint that fast into the gun.
Yeah.
And I also don't know how well this particular marker would hold up with the bolt being cycled that quick. So 10 BPS will do it for me on that. Anywhere from like single shots, like a semi-auto mode, up to 10 BPS will be the variable rate once the gun's autonomous. But the other part was getting the eyes to work.
Good defense.
Yeah, so I would never advocate sticking your finger down in the chamber or the breech of a gun, but
just this once.
There's no gas here, so I'm not too worried about it. But so the eyes are looking for a paintball to break that beam, and so once my finger goes in, it's going to simulate that, and it should start firing.
Oh, that's sweet.
So in this particular test, it's locked into firing mode. It's always trying to shoot, but if there's no ball in there or nothing breaking the beam,
no good.
It's not going to do it. But check this out. This is what I've actually been working on the last few days. Here's the Raspberry Pi. That's my servo controller right there, and this is the board that I finished building this morning. Mm-hmm. And this has 3 circuits. I still have to add one more circuit to it. This is power in. It can handle anywhere from 5 to 35 volts DC. Each of these things standing up convert it down to 5 volts DC. This particular chunk is the power output section for the Ras Pi, power output section for the servo controller, and this is the power output section for the gun. And you can see it's got a much bigger cap in there so that the solenoid can fire without browning out anything.
Cool.
But the way that they're
so
isolated...
that's protecting against your solenoid... What were you talking about? The leak? Is that what it was called? The solenoid bumping back and sending a voltage down the line?
So there's actually a diode in there that handles
okay.
that. There's sort of like a backwards current flow of tremendous strength. Very briefly,
mm-hmm.
and that diode keeps everything basically keeps you from frying your transistor.
Mm-hmm.
No, but the capacitor is there to help actually trip the solenoid without like overdrawing from wherever your power source
Oh,
is.
guy, I guess you've got to store up a pretty good voltage to shove through that thing, don't you?
It's probably not as much as I should put on there, but it was the biggest one I had. So
Yeah.
anyway, so here's that's the lead for the solenoid. That's the lead for the infrared emitter. That's the lead for the infrared detector. And
Cool, man.
yeah, everything's
That's lovely. You got it
hooked up here.
routed through all purdy.
Using a couple of GPIO pins. Yeah, I'll go get some cable wraps and put those on there. I figure once the code's in place and it's actually doing things and we're ready to take it out and actually use it in a field setting, I'm going to outfit it with some fiberglass shielding to help it survive, being hit.
That sounds pretty sweet, man. Sacrifice to
Yeah.
what was it? This is not a rail, is it?
2007 rail.
2000. Okay. What is?
That was the Apex barrel I originally had on there, but it's so front heavy. It was not working out well for the movement tests.
Yeah, it's clear to see how that would slam right into the black box.
So I'm gonna have to give it some awareness of what coordinates it can and cannot move to.
Yeah.
And I want to kind of keep it from crossing over in front of the box too much anyway, because if the barrel gets out in front, it's going to confuse the camera. So.
Well, I think it'll be easy enough to figure out what this angle here is from the gun to the box and just say, if it's further than that, use the other side. That's all there is to it. This is beautiful, dude. I'm so impressed.
And what I may do, there's a little bit of struggle now that I've actually put the weight of the gun in there.
Yeah,
And as long as the barrel's
doesn't look
in
like
there,
it cycled all the way back up there.
Yeah, see, so if it doesn't complete it in time, the next instruction just overwrites it. So
Gotcha.
anyway, what I may end up doing is actually getting a smaller drive gear to go on the servo and a bigger gear to mesh with that.
Well, and does it move better when the barrel's attached? Because right now it's very back heavy.
Yeah, it would balance better.
Yeah.
Definitely move better in that position.
All right, well, I'm going to kill it.